Okay, so we're going to go ahead and begin by looking at how do we model and solve equations involving one step, one variables. We're particularly going to be looking at those problems that involve multiplication and division. So the first thing that I want to look at is we're going to take this equation, 2x equals 10, and we're going to model that. So I'm going to show you here. I have my first step listed over here. Which just says to draw a model. And then our model will look like this. Notice that I have the equation written and I have it split into two sides. Let me zoom in a little bit. And then we have two bars that are the x's, and then we have 10 positive units. Okay. Step 2 says we're going to move an equal amount of units into each x bar. And so to show that, I'm just going to group these 5 here, and I'm going to be placing them inside, or showing that they would be placed inside each x bar. The value is what remains in one x bar. So we're looking at x equals 5 positives. Okay. We've also looked at using substitution and the inverse operation as a way to check this work. So I'm going to start by rewriting the equation. We have 2x equals 10. And in place of x, we're going to put the value that we just found. So it's 2 times 5 equals 10. Now, is that a true statement? Does 10 equal 10? Yes. So therefore, our solution is correct. The other way to show this is to use the inverse operation. And you'll find that the model might become a little confusing, but the inverse operation strategy might be easier for you to use. You are required to know both to kind of recognize what the model is reading or how to use the models, and also how to use the inverse operation to solve these types of problems. So in this case, the current operation that is shown here is multiplication, 2 times x. So we need to do the inverse operation. The inverse of multiplication is division, so we would divide both sides by 2, keeping in mind that this is like balancing, right? And so whatever we do on one side of the equation, we must also do to the other side. So when I divide 2 by 2, I get a 1, so they cancel each other out. And we don't have to write 1x because x by itself means that there's only 1x. And what is 10 divided by 2? 5. That matches our original model. I'm sorry, can't even see all that work. It matches our original model answer as well, and so we have the correct solution identified. Finally, we want to see what would this look like if I had to graph the solution on a number line. So we've been practicing by placing the 0, putting the value of x and its opposite. And this would be represented by a closed dot on a positive 5. Okay. Now let's look at a division example. I have the example x divided by 2 equals 3. So I'm going to start by rewriting that. And I'm going to split this into 2 equal sides. We're saying what is on the left-hand side of the equal sign is equal to what's on the right-hand side of it. So the steps here are going to be the same initially. We're going to draw a model. Okay, so the division model will look slightly different. We're going to have 1x. I'm going to draw that x a little larger so we can see what's happening to it. Okay, so I have 1x. And this time I'm going to divide it into 2 parts because it's divided by 2. So I'm just going to split this in half, if you will. And on the right-hand side of our equal sign, we have 3 positive units. Okay, so here our model is showing we have x divided by 2 equals 3. So our second step here would be to move all the units, move all the units into each part of the x. Okay, and I'm going to show that by grouping these 3, and I'm going to place or show with the arrow here. So I would have 3 positives in this part, and I would also have 3 positives in this part. So our solution here, x is going to equal the value of the units inside the entire bar. Okay, so be careful not to just think that it's only going to be half of the bar. We're actually looking for the value of the entire bar. And here we have x equals 6. Okay, now let's go ahead and check our work using substitution and the inverse operation. And then we'll also go ahead and graph it. So the original problem was x divided by 2 equals 3. Now as I'm using substitution, instead of x, I'm going to use this value that we found, and so we're going to have 6 divided by 2. Does that equal 3? Okay, and we know that 6 divided by 2 is 3. Therefore, 3 does equal 3. Our solution checks out. When using the inverse operation, start with the original equation. And we need to see that since this is showing division, the inverse of that would be to multiply both sides by 2. When I multiply the left-hand side by 2, the 2's actually cancel each other out, and we're left with an x. And we have 3 times 2, which equals 6. Again, that matches our original solution. Therefore, we have the correct answer. On a graph, I want you to graph 0, 6, and negative 6. And we'll show the solution to this equation as a closed dot on 6. Okay. Now, I'd like you to try 2 of these on your own. The problems themselves are going to be listed here. Come out a little bit. We're going to try to do 2 of these. So we have 3x equals negative 9. And then we have x divided by 3 equals negative 5. So this would be a good time for you to pause the video, try to solve this problem using the model, substitution, the inverse operation, and finally graphing your solution. So we want to capture all 4 of those pieces here. Okay, so pause the video and work out these problems, and when you have them worked out, come back, unpause it, and let's see if you have the same solution that I have. Okay, so you should have, or what we've been practicing with, is kind of showing our balance or our scale. So I'm just going to split that for both of them. I'm going to start with the first problem, which is 3x equals -9. I'm going to model that by showing 3 x bars. These are all positive x's and 9 negatives. I'm going to keep these organized in a way that would be easy to move. Okay. The second step when we modeled this type of equation is to move an equal amount of units into each x bar. And so this time we're going to move those 3 negatives into each x. So the value here of x equals what's inside 1 bar, -3. Okay. Let's check our work using substitution. Instead of the x, I'm going to have a -3 here. So we show 3 times -3 equals -9. And is that indeed true? It is. When you have a positive times a negative, your answer is going to be negative. So this is the correct substitution, or the correct solution as it matches. Let's solve this using inverse operations. Okay. The operation that is currently represented is multiplication. This is 3 times x. And so the inverse of that would be to divide both sides by 3. Remember, whatever you do to one side, you must also do to the other side of the equal sign. So we have x equals, now I have a -9 divided by a +3. So my answer is going to be -3. Okay, and again, that matches our original solution. What is this going to look like on a graph? We have 0. We're plotting 3, or labeling 3 and -3. And to show this answer, we would have a closed dot at the -3. Okay. Let's take a look at our our division problem. We had x divided by 3 equals a -5. So this time I'm going to have a larger bar just so we can show what's happening. I'm going to divide it into 3 pieces. And I have 5 negatives. 2, 3, 4, 5. The second step when we were dividing was to take all the units and place them in each part of the x bar here. So rather than draw those out, I'm going to label this. I have 5 negative, 5 negative, and 5 negative here. So the value of x is the entire value, or the value of the entire bar, which is going to be -15. Okay. Using substitution, start with the original equation. X divided by 3 equals -5. We're going to substitute -15 in the problem and see if that is equivalent to -5. So -15 divided by 3 is equivalent to -5. Therefore, -5 equals -5. Our substitution shows that we have the correct answer. Solving this using the inverse operation, we're going to go ahead again and start with the original equation. And this time we're showing division, so the inverse of that would be multiplication. So I need to multiply both sides times 3. What happens here is the 3's cancel out. We have x equals -5 times 3 would be a -15. And again, that solution matches the original solution we got here. Okay, so far we're looking really good. Everything's lining up. And then the last part here, we're just going to graph the solution. I'm going to start with a 15, Also going to include a negative 15. And we're going to graph this with a closed dot at the negative 15. Okay, so this should be your quick mini lesson on how to model and solve equations using the bars and the units. Also, how to check your solution using substitution, how to solve the problem using inverse operations, and finally, how to graph your solution on a number line.